Hi class, I am going to go over what an ICE table is. This is covered in section 5.3 in your book. If you have the ebook, then there's a video that Tyler DeWitt, these hands that you see throughout the book is Tyler DeWitt. He's on YouTube. He does a lot of chemistry problems. So if you need help, he would be one I would suggest to look up. And, you know, his voice will sound very familiar instantly if you've been watching his videos. When you get to 5.3, there's a section that he's doing a video and he breaks down how to do an ICE table in this video. I am going to give a little bit more information in case you choose to do an ICE table. You don't have to, it's not required. You can do all of these calculations without them, but sometimes they're a little easier. Setting up takes a little bit more time, but in the long run, it's actually easier to do the problem. So an ICE table is a simple organizational tool to solve stoichiometric problems. If you go on to 24B, you will definitely learn ICE tables because you will do them with equilibrium. So first thing is you need to construct an ICE table. I'll show you on the next page. Decide the info that should be inserted into it, balanced reaction moles, what you're going to work with to get the calculation completed. Convert everything to moles. For us right now, for 5.3, to determine limiting reactants, we work in moles. Yes, you can go on to grams after you're done, but while doing the ICE table that I'm going to show you, it's just going to end in moles. This will help you determine the limiting reactants and as well as anything excess that's left over. Determine the change amount for all substances listed in the table and then complete the table, means finish all the calculations. So I'm going to show you what an ICE table is. I've taken a reaction that we're actually going to do. This is from your book. It's one of the problems in the back. ICE, your book actually has it as ICF, but I learned it as ICE, and if you do a Google search, it'll come up as ICE chart. I stands for the initial concentrations or pressures or whatever it is that you're starting with. C is the change. This is when the chemical change actually occurs. What's going to be lost, what's going to be gained. And E represents equilibrium. Like I said, these are for equilibriums. It's how I learned it as a student, but you can use these for limiting reactants as well. And I just call it end amount. Now, where F in your book is for final amount. So it means the same thing, but ICE tends to be a little easier to remember. So here we have a reaction of copper solid plus silver nitrate, and this produces copper 2 nitrate and silver as a solid. So let's take a look at this. We have a box, and if you notice, I did my best to try to make each of these reactants and products under one box. This is because that box is going to cover what is happening with that compound. So we have that. We have an initial amount. This is going to be moles, change in moles, and the end of moles. So what we're going to be doing by the time this is done is determine which is the limiting reactant, which one will be used up completely, because the limiting will always be the one used up completely, how much is left of the excess, and how much was produced from that limiting reactant. So I'm going to give you the problem. This is problem 48, page 258. Problem number 48, page 258. And this is the exact problem from it. So it says calculate the number of moles of each product as well as the number of moles of excess after 0.272 moles of copper and 0.576 moles of silver nitrate are combined. Pretty much they are reacted. So we're given enough information to determine which of these is limiting. And this is also a sign of a limiting. Limiting reactant problems tend to give you both mole amounts or mass amounts of both reactants. Other problems don't tend to do that. They tend to give you one and you can use it to figure out the rest. But when you're given both, that means that you have to figure out which is the limiting by determining it. I'm going to show you two different steps on how to do that with this table. So I'm going to take that information and I'm going to plug it in. So we have the amount of the copper, we have the amount of the silver nitrate, and we should always have zeros because this reaction has not occurred yet. So there is nothing to put in these, but do not leave them blank. It can be a little confusing if you do, so always put zeros. Just a suggestion. Now, I'm going to show you two ways to determine the limiting. The first way is the way that you would normally do stoichiometry. You would take the amount and you would look at the coefficients and you would pick a product. And in this case, it doesn't really tell you which one, so it doesn't matter which one you pick. I tend to pick the one that has no coefficient because it makes it easier. So we pick copper 2 nitrate, or your book did, and it's given an amount. This is a 1-to-1. and it's one here and a one here, so that's usually right. Now, second here, it is right, I mean. Second one, we have 0.576 moles of silver nitrate. We have also picked, you have to pick the same product, and this has 2 moles of silver nitrate. So this gives us an amount of 0.288 moles of copper 2 nitrate. This being the smaller amount, copper is the limiting reactant. But I'm going to show you another way to do this. So if you, in this video, I believe that Tyler DeWitt also shows you that way as well. So this way only works for ice. It doesn't, I would not suggest it. I mean, you could probably do it in regular reactions to check on limiting, but I'm used to doing it only here, and I tend to, when I have it regular working these out without an ice table, I tend to do it this way. I don't see why it wouldn't work, but I just kind of stuck in my way of doing things. So this is determine the limiting reactant by formula. So you have your reactant mole amount, and you just divide it by the coefficient. So here we have copper, and I take the amount, and I divide it by the coefficient. So this tells me it's 0.272. So now I'm going to take the silver, which is 0.576, and I'm going to divide it by 2. And it's going to give me 0.288 moles. So I don't do anything with anything over here. I simply use the information given here, and it still shows me that copper is the limiting reactant. This tends to only work with limiting. I wouldn't try to force this into any other type of reactions. You know, I just be on the safe side. But this will definitely tell you the limiting reactant. So I put an LR by the limiting reactant. I tend to do this just as I'm working them out, even in person, like on piece of paper, because I always need to remember which is one I'm working with, because everything in this reaction is going to be based on copper. So now that we have that, we are going to figure out the change amounts. So the change amounts are working it through. So you could do this, if you've been doing these long enough, you actually don't need to do this on paper. But I'm going to show you how to do this because you can just plug in the calculator, the steps. So the first thing we're going to do is we're going to determine how much is copper nitrate, copper 2 nitrate. So you take the mole amount, and it's a 1 mole to 1 mole, and I will plug in 0.272 here. And I'll put a plus sign because it's new. It's something that's, because of the reaction, it's being produced. Here, I did it for it only says silver here, but if you notice there's a 2 here and a 2 here. So these are going to go through the same steps of 0.272 mole, 1 mole of copper, 2 moles of silver, or 2 moles of silver nitrate, and it's going to give me the same amount. So on this side, I'm going to put a plus 0.544 mole, and here I'm going to put a negative 0.544 mole, and I'm going to put a negative 0.272. So let me show you what that looks like. This is because we're using all of the amount, so the limiting is gone. Here, this is the amount that was reacted with, the 0.272. This is being produced, and this is being produced. So now it just comes, I didn't mean to put a 0 there, I jumped ahead, but that's exactly the next step. At the end amount, we're going to plug all these in, and what it shows you is the excess. This is the amount of excess left over on the excess amount. Limiting is gone, should look like that. You bring down the amount that was produced for the copper 2 nitrate, and you bring the amount that was down for the silver. These are the final number of moles for each of these components in compounds in this reaction. So if you needed to determine mass, now you have enough information that you could go that extra step to get the mass of any of these. So this is not a difficult thing. It takes more time to set it up, but when you're dealing with excess, it's kind of easier to do it this way than to, yes, you can do regular calculations, but this gives everything a lot clearly, and you can see the actual steps of what's happening. So you're going to see, if you do the practice problems, you're going to see boxes like this. This is what it is, and Tyler DeWitt did a video, but I just wanted to make sure to confirm that if you chose to do this, how to actually set it up, because sometimes even though the book shows tables, they may not be exactly clear, and there's no instructions except for his video to actually how to do this. So that's it. I suggest you do this problem yourself. Don't look at this, even though you've seen it now, but go and do it yourself. Go through the steps, and then come back and check if your answers match mine. And in that way, it'll reinforce, if you want to do this, that you know the steps to do it. And that is it. Thank you.